Okay, last subject, graphing relationships. Okay, let's look at number one. Oh, didn't work. A giraffe is born 6 feet tall. So here's my height on my y-axis. He's born at 6 feet tall. So here's, let's say that's 6 feet. And over time, he continues to grow at a steady rate. So over time, here's my time. So as time increases, his height increases. And then he's fully grown. So he is no longer, his height increases, but time still increases. So there's my graph of number one. Sky, please sit in a chair. Number two, the price of a used car is discounted $200 each week. So say I got a car price way up there, and for a week, 1 week, it's at a certain price. Then for the next week, I'm going to drop the price, and then for another week, and then I'm going to drop the price another $200, and that goes on and on until the car sells or it's a freebie. Number three, a city planner buys more buses as the population of her city grows. So I'm assuming that the city planner has buses already. So say it has that amount of buses already. So as the population increases or grows, the number of buses increase. So it's just going to be a steady increase. Number four, Joseph is skydiving. At first he is free falling rapidly, then he releases his parachute to slow his descent until he reaches the ground. Okay, so here's the height above the ground. So real quickly dropping, but then all of a sudden he opens his parachute and gradually hits the ground, right? Number five, Rebecca turns the oven on and sets it to 300 degrees Fahrenheit. She bakes a tray of cookies and then turns the oven off. So the oven, the temperature is going to rise, stay flat for a while, and then decrease. So it's going to be graph number three. Number six, Leon puts ice cubes in his soup to cool it down before eating. So the temperature is going to be hot, then it's going to go down and cool. So it's going to start off hot, so it's either going to be graph 2 or 4. Then cools, gets to a point where the ice melts and stays at temperature. So it's going to be graph 4. Okay, number 7. Barley as a fluid or temperature rises slowly. So rising slowly is going to be 1 or 3 until it reaches 101. And that's it. That's all that happens. So rises slowly. Here's 101. It's going to be graph 1. I bet you number 8 is going to be graph 2. Okay, on a hot day, Karen walks in and out of air-conditioned building. So it's hot, she cools down, spends some time in air conditioning, then she goes back outside. So it's going to be graph 2. Like I said, pretty sure it was going to be graph 2. You're welcome. You guys could do page 2. Uh-huh. Okay, page 3. Number 1, a train pulls into a station and lets off its passengers. So the speed of the train is going to decelerate. So we're going to need this one until the speed drops to 0. So it's got to be B. Man takes a ride on a Ferris wheel. Now, we could eliminate 2 graphs right off the bat, right? Shh. Hey, quiet. Okay, now this is our time axis here, our x-axis. We could never go back in time, can we? No, so we can eliminate D and A. Okay. Gentlemen, shut up. It's got to be B. Yeah, because it goes up distance from the ground, then it comes around, then it goes up and down. Doesn't vary. Got to be B. Number 3. A woman climbs a hill steady pace and then starts to run down one side. Shh. A lot of my students last class picked B too. Okay, now let's think about what's happening in B graph. The speed increases sharply, and then she gets to a certain point and her speed decreases. Now, if she's climbing a hill at a steady pace, okay, I can see, does that even fit steady pace if her speed's increasing? And then runs down the other side, what's going to happen to her speed here? Yep, it's going to increase. Her speed's going to increase. So the only ones that have increasing speed after a steady speed are D and A. It's got to be A. Yep. Now, you're right. Don't get in the habit. Don't get caught up in the fact that this looks like a hill. Okay? Yeah, that's what it says. It climbs a hill, so a lot of students automatically pick the graph because it looks like the hill. Okay, what about 4? Child swings on a swing. Okay, so he starts way up on top. No. B. So he starts a little bit, and then he goes up, and he stays up there? Oh, he comes back down. Oh, here we go. Hey, yeah, these are kind of tricky. They look easy, but they're kind of tricky. Gentlemen, quiet. Child climbs up a slide and then slides down. It's got to be A because it looks like a slide, right?
No, I said B.
B?
Yeah.
So he climbs up a slide. So he climbs, stops, then all of a sudden gets up, stop, climbs. Nope, can't be B. So A because it looks like a slide? Okay, so he's running up the stairs because his speed is increasing. Then he gets to the top, waits a while, and then as he's sliding down the slide, his speed decreases. Well, that just doesn't make sense at all. It could be D or some shit, huh? Okay, well, let's look at D. Okay, he's climbing the stairs at a steady pace, so we're good there. But then he reaches the top and slides down, and his speed decreases. Yeah. All right, it's got to be C. Okay, he's climbing the ladder. He's climbing the ladder and then gets to the top. and is deciding to go down. But then he goes down the slide, so his speed goes up really quick. And then he hits the ground, and his speed stops. Hey, guess what? Looks like C.
After 3 tries.
That was all me.
No, what was it?
That was.
You said D.
I said A, B, D.
And then you said C when you
Yeah.
stopped.
That was me.
Let me do number 7. Because my last class couldn't handle the chart. All right, number 7. Richard types for 3 minutes at the rate of 35 words per minute. He takes a 2-minute break and then types for 3 more minutes at the rate of 25 words per minute. Which graph represents Richard's time at the typewriter? Okay, let's, gentlemen, shut up. Okay, so for 3 minutes, he types at 35 words per minute. So 3 minutes, 35 words per minute. Please don't throw things in my classroom. Then he takes a 2-minute break. How many words does he type?
0.
Good man. And then he types for 3 more minutes at the rate of 25 words per minute. So 3 more minutes at 25 words. Well, the words only add up to what, 60 here, and the minutes add up to 8. Here's my words. This one says it adds up to like almost 200. So I'm going to eliminate that one. Here, it starts out at 0, types for 3 minutes, and has 35 words. Good. Here's another 2 minutes with 0 words. Good. And then he types for another 3 minutes, gets to 8, and is a total of about 60. Hey, this looks pretty promising. All right, number 8. It should be A. Now, number 8. Sarah walks home from her home to the store. Where's the store? Over here. Here's home. All right, so the distance of home is going to increase over time as she goes towards the store. Halfway to the store, she realizes that she forgot to bring money. So she turns around, returns home. So where should I go from here? Should I go back down? So I'm going to go back in time? Back to the future? You got a time machine? Time is on your side. Don't forget, this is just distance from home, so. Okay, so I'm going to do a UE? So you're saying I should do a UE and go back home? So the distance gets shorter to back home, but we start like taking time off the clock.
No.
You just went back home to get your wallet.
Yeah, but I can't go backwards in time. Yeah, why can't I just go back down?
Because, oh my God, that's not home.
Yeah, I am. I'm back home.
Oh,
The distance from home.
oh,
And then she goes to the store.
you say her home is like a big house, a real big house.
I don't know what that has to do with our little story problem. What? What does the size of her house have to do with anything?